You can see the universe, but the universe can never truly see a black hole. A black hole is the only one-way transparent object in existence. It can see everything around it, stars, galaxies, even passing spacecraft. But all observers can detect is the distorted halo of light circling its edge. Its true body remains hidden in perfect, absolute darkness. This isn't magic, it's physics. A black hole's gravity is so intense that even light cannot escape, making it forever invisible. A blind spot carved into space-time, the first image ever captured. On the 10th of April 2019, humanity pointed 8 radio telescopes toward one such object and produced a photograph that stunned the world. It took 200 scientists, 10 years of work, and the data equivalent of 5,000 years of movies to create a single image. Yet even then, what appeared was only a glowing orange ring. The black hole itself remained hidden in the dark center of that halo, a power that warps reality. Viewed from afar, a black hole bends the very fabric of reality. Stars behind it appear warped and twisted, as their light is bent around the black hole, before finally reaching our eyes. Approach it closely, and time begins to distort. Clocks tick slower and slower, while the distant universe ages rapidly. A traveler could experience moments, while millions of years pass outside. Loved ones, civilizations, all turn to dust in the blink of cosmic time. How a black hole is born. Surprisingly, a black hole begins life as a star. Imagine a giant star, more than 20 times the mass of the sun did. After millions of years of burning, its hydrogen fuel runs out. The outward pressure collapses, and the entire star falls inward violently. Outer layers crash into the core at tens of millions of kilometers per hour. Temperatures climb into the billions. Then, a supernova erupts, a blast brighter than an entire galaxy. When the explosion clears, what remains is a core crushed into a point of infinite density. The birth of a black hole, a hunger without limit. Once formed, a black hole becomes a relentless consumer. The one at the center of the M87 galaxy is 6.5 billion times the mass of the sun and devours the equivalent of 90 Earths every single day. Around every black hole lies the event horizon, a boundary of no return. Cross it, and nothing, not even light, can escape. When a star drifts too close, tidal forces stretch it into a long, thin strand. A process known as spaghettification. The star breaks apart into atoms, forming a blazing disk spinning near light speed, heated to hundreds of millions of degrees, before the black hole consumes it completely. Where time freezes. If a spacecraft approached the event horizon, a distant observer would see it slow down and eventually freeze in place, paused forever at the edge. But from the traveler's perspective, time inside the ship would appear normal. They would fall inward smoothly, while the universe outside accelerates, stars flickering, galaxies racing, millions of years passing in seconds. The distortion would be enough to fracture the mind. The mystery inside, at the core of every black hole, lies the singularity, a point with zero volume and infinite density. Here, Einstein's relativity fails, quantum mechanics fails, every law of physics collapses. Some scientists speculate that the singularity could be a doorway to another universe. Others believe that time itself disappears there, past, present, and future, compressed together. No one knows the truth, because nothing that enters ever returns or sends a single signal back. Humanity's growing understanding. In 2020, 3 scientists received the Nobel Prize for proving the existence of black holes. And in 2022, astronomers captured an image of the black hole at the center of the Milky Way, Sagittarius A*, a monster 4 million times the mass of the sun and located 26,000 light years away. Even more astonishing, nearly every large galaxy houses a supermassive black hole at its center, cosmic anchors holding galaxies together with immense gravity. Do black holes live forever? No. Stephen Hawking predicted in 1974 that black holes slowly evaporate through quantum processes called Hawking radiation. The process is unimaginably slow, requiring 10 to the power of 100 years for a black hole to fully disappear, far longer than the current age of the universe. In its final moment, a black hole would explode. With the force of millions of hydrogen bombs, black holes shape the universe. Astronomers estimate that the Milky Way alone may contain over 100 million stellar mass black holes, and in 4.5 billion years, when the Milky Way collides with the Andromeda Galaxy, their central black holes will spiral together and merge into an even larger monster, releasing gravitational waves that ripple across the universe like cosmic fireworks. The final truth: black holes are the most extreme objects ever discovered, the graves of stars, the architects of galaxies, perhaps even seeds of new universes. They bend space-time, capture light, and challenge every law humans think they understand. A black hole is the eternal riddle of the cosmos, the unseen abyss that no eye can ever look into.